Problem 21. Samantha lives 2 blocks west and 1 block south of the southwest corner of City Park. So let's draw this. This is the southwest corner of City Park. City Park. This is 2, this is 1, and here is home. And the school is to the southwest corner. She bikes on street to the southwest corner of City Park, and her school is 2 blocks east and 2 blocks north of the northeast corner of City Park. So that's 2 blocks to east and 2 blocks to north. And here it is her school. So how many ways are there for her to get from her home to her school? So first, let's look at from home to southwest corner of City Park. There are 3 vertical lines. That means there are 3 ways from home to southwest corner of City Park. And then when she arrives at the southwest corner, she takes the diagonal route to get to the northeast corner of the park. After that, she needs to go 2 blocks to the right and also 2 blocks up to get to her school. So how many ways are there from the northeast corner of the city park to her school? Because there are total 4 blocks of length. So it contains 2 U's, 2 ups, and 2 right. And so that's the arrangement of the 4 letters, and that's 4 factorial in total. And because the order of the U's and the R's do not matter, so we divide that by 2 factorial, that's for the 2 U's and the 2 R's. And that gives us 6 in total from the northeast corner to school. And 3 multiplied 6 equals 18. So that's 18 ways in total. The answer is E. Problem 22. To make the grid 60 toothpicks long and 32 toothpicks wide, we will have 61 vertical lines of each line contains 32 toothpicks. That's 61 multiplied 32. And also we will have 33 horizontal lines that each line contains 60 toothpicks. So we need to add 33 multiply 60. And that equals 1952 plus 1980. And that's 3,932 in total. The answer is E. Problem 23. Because the arc of the semicircle on AC has length 8.5 pi, that means pi multiply AC divided by 2 equals 8.5 pi. And we can get AC equals 17. And because the area of the semicircle on AB equals 8 pi, that means pi multiply AB divide 2 square equals 2 multiply 8 pi. And we simplify this, we get AB equals 8. Because angle ABC of the triangle ABC is a right angle. So that means BC equals the square root of AC square subtract AB square. And that equals 17 square subtract 8 square. That's 289 subtract 64. It equals 15. So the radius of the semicircle on BC will be half of 15. That's 7.5. Problem 24. To solve this problem, let's first draw a line that extends AD to the bottom and cross FG at L. Because AD equals DL, and D is the midpoint of AL, and DC is parallel to LJ. That means, let's assume AJ crosses DI at this point is K. So that means DK equals 1/2 of LJ. It also equals 1/2 of DI. That means K is the midpoint of DI. And because AD also equals IJ, so triangle ADK is identical to triangle JIK. Therefore, the shaded area of JIK can be converted to the area of ADK. Then we cross this out. So the shaded area, the ratio will be ABCD divide the total 3 squares, because the 3 squares are identical, so it equals 3 multiply the area of ABCD. And that equals 1/3. The answer is C. Problem 25. The ball has a diameter of 4 inches and starts at point A to roll along the track of the 3 semicircles. To solve this problem, we need to notice that the ball touches point A at its edge, not its center. So the center will be 2 inches away from A. Therefore, when the ball rolls along the semicircles for R1, the length will be pi multiply R1 subtract. Let's assume the radius of the ball is smaller r. And plus pi R2 for R2 because it rolls along the edge. When it goes along R2, it will be on top of R2. So that's R2 plus R. And for R3, it's pi R3 subtract the small r again. And let's simplify that. We get it's pi R1 plus R2 plus r3 subtract small r, and that's pi 100 plus 60 plus 80 subtract 2, and that's 238 pi. So the answer is A.